Welcome to Defenders, the teaching class of Dr. William Lane Craig. Today, The Existence of God, Part 11. And for more information and resources, go to reasonablefaith.org.
We've been talking about scientific arguments for the beginning of the universe, which is the second premise of the Kalam Cosmological argument. And today, I said we would turn to a second scientific confirmation of the beginning of the universe, which is the evidence from thermodynamics. According to the second law of thermodynamics, processes going on in a closed system tend to a state of disorder. For example, if we had a bottle with a closed vacuum inside, and we were to introduce into the bottle some molecules of gas, the gas would spread itself evenly throughout the bottle. It would be impossible virtually for all of the molecules to cluster down in one corner of the bottle and remain, for example. The reason for this is simply because there are far many more ways for the gas molecules to be disorderly in their distribution than for them to be orderly in their distribution. So that, according to the second law, if you have a closed system, that system will tend toward a state of disorder. Now, already in the 19th century, it was realized that the second law of thermodynamics implied a grim prediction for the future of the universe. For according to atheism, the universe is just one gigantic closed system, since it is all there is, and there's nothing outside of it feeding more energy into it. Now, what that seems to imply then is, given enough time, the universe will eventually run down so that matter and energy will diffuse themselves out evenly throughout the universe. The universe will become a sort of featureless soup in which all matter and energy are evenly distributed and no life is possible. And once the universe reaches such a state of equilibrium, thermodynamic equilibrium, no further significant change is possible. And scientists called this the heat death of the universe. But this unwelcome prediction raised a further puzzle. If given enough time, the universe eventually will reach a state of heat death, then why is it not now in a state of heat death if it has existed for infinite time, from eternity past? If in a finite amount of time the universe will arrive at a condition of heat death, then given infinite past time, it should have already arrived at such a state and should exist in thermodynamic equilibrium. Now, the German physicist Ludwig Boltzmann proposed a daring hypothesis to try to avoid this conclusion. Boltzmann suggested that perhaps the universe as a whole does in fact exist in a state of equilibrium. That there is overall in the universe an equilibrium state of heat death. Nevertheless, he suggested perhaps by chance alone there would occur random fluctuations from disequilibrium at various places that would produce, so to speak, little pockets of disequilibrium in the overall sea of equilibrium. And Boltzmann referred to these pockets of disequilibrium as worlds. And he suggested perhaps the universe we observe is one of these worlds. We are just a little pocket of disequilibrium in an overall sea of equilibrium. And eventually, in accord with the second law, these little pockets will dissipate and everything will revert back to an overall state of equilibrium again. Now, contemporary physicists have universally rejected Boltzmann's many worlds hypothesis as an explanation of the observed disequilibrium in the universe. Its fatal flaw is that if our world is just a chance fluctuation from an overall state of equilibrium, then we ought to be observing a much smaller world. That is to say, a much smaller pocket or region of disequilibrium, a much smaller ordered universe, because a small fluctuation from equilibrium would allow us to exist and observe the world, and yet it would be overwhelmingly more probable than a huge fluctuation from equilibrium, such as we observe in our universe. So that it would be vastly more probable that we would be observing a much tinier region of disequilibrium than the vast universe that we see. In fact, Boltzmann's hypothesis, if consistently carried out, would lead to a very strange sort of illusionism. It would be more probable that we do, in fact, live in a very tiny pocket of disequilibrium, and that the stars and the planets that we observe are all illusions, as it were, just pictures on the heavens, and not real stellar and planetary bodies out there. They're just images on the sky, so to speak, illusions, because that sort of illusory universe would be vastly more probable than a universe which has declined in entropy from a state of equilibrium over the course of 15 billion years to produce the universe that we see. And so Boltzmann's hypothesis would result in a sort of insane kind of illusory reality in which everything we observe in the heavens turns out to be unreal. And therefore it's been rejected by physicists today. Any questions so far about the second law and the implications that it had as understood in the 19th century? Yes, over here, Robert?
Bill, I know these theories are quite old now. How would the dark energy and dark matter that has recently come to be known to the world
I'll
figure
say
into
something
this?
about that in just another couple of minutes. Right now we're kind of surveying the historical background in the 19th century.
Okay.
And what we'll see is how more recent discoveries have affected these predictions. Okay, any other question on the problem? Do you understand the problem that the second law has generated? Yes, Amy.
Well, wouldn't Boltzmann's theory, as well as other theories of many worlds, run into just the same difficulty? If it's all existed from eternity past, wouldn't any fluctuations or any of that already have dissipated?
Well, what would be required to say is that these fluctuations are constantly forming, so that they are random fluctuations from an overall state of equilibrium, and therefore they never cease. They would just go back infinitely. Not that any one would go back infinitely, but they would dissipate and then pop up again and again and again, so that ours would just be a recent fluctuation is all, he would say. Yes, David.
I'll just add, Boltzmann was so disturbed by the implications of the second law and frustrated that no one else would buy into his attempts to get around it, that ultimately he committed suicide.
Oh my,
Yeah.
Really? I didn't know that. Okay, well that comes from a quantum chemist at UGA, so thank you for that. Sorry, George Tech. Trained at UGA, right? But at George Tech, sorry. Okay, well let's proceed. Now the expansion of the universe that was discovered during the 1920s, which we surveyed in recent classes, modified the sort of heat death that was predicted on the basis of the second law, but it didn't fundamentally alter the question. If the universe will expand forever, then it will never actually arrive at equilibrium, because as space expands, there is generated more and more room in which energy and matter can diffuse themselves. They have more space in which to spread out, and therefore the universe never actually arrives at a state of equilibrium. But nevertheless, as the universe expands in accordance with the second law, its available energy is used up, and it grows increasingly cold, dark, dilute, and dead. I was inspired in that description by Thomas Hobbes' description of man's life in a state of nature: mean, nasty, brutish, and short. And similarly, the universe's fate will be one that is cold, dark, dilute, and dead. It will simply become a thin gas of subatomic particles ever expanding into absolute darkness. No light, no life, no heat, just a universe in ruins. Now that's if the universe is expanding forever. Suppose, by contrast, that the universe is not expanding fast enough to overcome the internal pull of its own gravity. In that case, the expansion will grow slower and slower and slower until finally it will come to a halt, and then with increasing rapidity, everything will come together again into a catastrophic big crunch. Everything in the universe will eventually coalesce into one gigantic black hole, which is coextensive with the universe and from which the universe will not rebound. And so the universe will perish in this inferno of gravitational self-collapse. So, whether its end will be by fire or by ice, the fundamental question still remains the same. If, given sufficient time, the universe will reach such a state, then why is it not now in such a condition if it has existed for infinite time? Now, as we move into the 21st century, very recent discoveries have indicated that the cosmic expansion is actually accelerating. That is to say, it is speeding up. And this is a result of this dark energy that Robert had mentioned. There is a kind of anti-gravitational force or cosmological constant that causes the universe to accelerate in its expansion. Now, in an accelerating expansion, because the volume of space is increasing so rapidly, the universe actually gets farther and farther away from equilibrium because the volume of space is growing so quickly. But although it grows farther and farther away from a state of equilibrium in which matter and energy are evenly distributed, nevertheless, the acceleration of the universe's expansion only hastens its demise. Because now what happens is that different regions of the universe become increasingly marooned or causally isolated from other regions of the universe, so that each marooned region becomes dark, cold, dilute, and dead, and suffers thermodynamic extinction. So again, the question arises, why isn't our region in such a state if the universe has existed already for infinite time? Any question about the way the second law looks in its contemporary applications then to cosmology? Yes.
What role does the dark matter play in accelerating the universe?
That would be the force that causes the expansion to proceed more rapidly. It's related to the inflationary expansion in the early period of the universe that makes the universe expand at an exponentially fast rate. Then it slows down to its more leisurely rate that we've been experiencing. Then when it reaches a certain density, this cosmological constant kicks in again and causes the expansion to accelerate even more rapidly. Yes, Jim?
Just a little off topic, but do any of these conflict with the Bible, with Revelation? I mean, isn't it possible that what the Bible's saying is the end is the end, and there's a new beginning?
We talked about this in the section of the class on the doctrine of the last things. And as I recall, what I did was I contrasted the predictions of physical eschatology with those of theological eschatology. That is to say, what physicists say will be the final things and what the Bible says will be the final things. And they are certainly different in that it's clear that Christ will return before humankind reaches a state of thermodynamic extinction or even extinction as a species. That Christ will return while there's still life on this planet. So what we have to say, I think, as Christians, is that these predictions of physical cosmology or physical eschatology are projections of present trends into the future. They describe what would happen under the conditions, all things being equal. That is to say, there's no outside interference by any other supernatural factors. But as Christians, we believe, of course, there will be interference. God is going to roll up the scroll of human history and bring the universe to an end. So these are at best projections based upon the laws of nature and present conditions of what would happen, all things being equal. Yes?
Bill, I've noticed a fascinating trend in the science programs. The astrophysicist, and they'll speak of an evolutionary theory of the universe, but they'll give it the kind of overall evolutionary sort of meaning that life has. In other words, as if the universe is an entity. And they were talking about the most recent theories on the development of stars, and with the Hubble, they took pictures of these gaseous clouds that they believe were the birthplaces of stars.
Yes.
So could you comment on that idea?
If we remember or think that the word evolution, taken strictly, simply means descent with modification, then what that would mean is, for example, that galaxies begin, say, as more nebulous clouds of gas and dust, and then condense into stars and then into different shapes and forms. So there's a whole study in cosmology of galaxy formation, the morphology of galaxies and how they form. And this could be called galactic evolution. But there's nothing corresponding to the mechanisms of genetic mutation and natural selection with respect to these things. Now, there have been some speculative theories proposed for cosmic evolution by people like Lee Smolin, but they've been largely discredited. For the most part, the word evolution, when it's used of non-living things, has to simply mean that things change over time and go through a process of alteration. And that's not significant, I don't think, in an implied
they were speaking in the tone and inflection of what they were saying.
Well, that would be a faith commitment, as you know, because there isn't any good evidence that the universe is infinite in the past. I mean, quite the contrary. That's very problematic, and nobody knows how to craft a model of the universe that could be extended infinitely into the past. And the present problem, the laws of thermodynamics, are just one reason for that difficulty. Yes, Bob.
Bill, present eschatological doctrine doesn't really see the end of the universe. It sees merely a remodeling or replacement. And at the end of Revelation, we read about the new heaven and the new earth, roll back like a scroll and totally remodeled. So I don't know that, and of course this, as you say, this doesn't contradict science, because whatever's going on here, God just simply intervenes, you know, and
right, which science can't contemplate. It can't contemplate the intervention of a supernatural deity. It simply takes present conditions and the laws of nature and extrapolates them out into the future.
And these doctrines are, of course, the conservative view, also, but even the more liberal eschatologists have no problem. The amillennialists, which comprises most of Christendom, have no problem with the idea of a new heaven and a new earth. They just say, oh, that's eternity, and we just know very little about that.
Right. The point is, I think, that we would have to say, on a Christian view, the human species on this planet is not going to become extinct. That before that can happen, Christ is going to return and bring about the end of history. Whereas if there were no end of the world, eventually life on Earth would become extinct, and eventually life throughout the universe would become extinct. There would be nothing left. And that's not going to happen. All right, what we want to do now would be to look at some attempts to avoid the beginning of the universe that is implied by the second law of thermodynamics. And we'll begin to do that next Sunday then when we meet together and show why all of these attempts to avoid the beginning of the universe thus far have failed. So we'll see you next week.
The copyright for the content of this recording is held by Dr. William Lane Craig. For more, go to reasonablefaith.org.